Assalamualaikum warahmatullahi wabarakatuh to Madam. My name is Nur Aiman Nabila binti Ishaq. My matric number is 20204888804. I'm the representative of Group 7 who would like to conduct a presentation about Experiment 1 titled Coulomb'S Law.
And this is my group member. In this presentation, I will explain about objective, theoretical background, methodology, presentation of data, analysis of data, discussion, and conclusion. First is objective. The first objective is to satisfy Coulomb's law experimentally, to study the parameters that affect the electric force, to find experimentally the electric constant K. Next is theoretical background for Coulomb's law. The magnitude of the electric force that a particle exerts on another is directly proportional to the product of their charge and inversely proportional to the square of the distance between them. Mathematically, the magnitude of this electrostatic force F acting on two charged particles Q1, Q2 is expressed as F equal to K Q1, Q2 over R square, where R is the separation distance between the charged object and K is a constant of proportionality called the Coulomb constant K equal to 9 times 10 to the power of 9 Newton square over Coulomb square. Methodology. Methodology for experiment part 1. First, we need to click the link given and the charge Q1 and Q2 is fixed and the value is written in the table given. Second, the distance between the two charges as shown in the table is changed. The force value for each distance is recorded. And the last step is the table is filled by finding the value of R square and 1 over R square. For part 2, we also click the link below and it appears same as the previous experiment part 1. Second, Q is controlled and had been fixed at 5 new Coulombs. The distance between the two objects is fixed at 6 cm. The value is recorded in the table too. For the last step, the charge of object 2 is changed as shown in the table 2 and for each Q2 is recorded for the electric force between the two objects. Next is presentation of data. This is the data for part 1 and this is the data for part 2. Analysis of data. For part 1, the first question is use Excel software and plot a graph relate F and R. Comment on the graph. And this is the graph that we get. For questions 2, use Excel and plot one more graph relate F and 1 over R square. Use the graph to find the electric constant K. So this is our graph. We use the straight line equation y equal to mx plus c as the slope represent as electric constant K. So we get 0.08 Newton square over Coulomb square. Next question is calculate the percentage error in K. So we use the Coulomb's law formula and we substitute the value into the formula and we get the percentage which is 0%. For part 2, the first question, use Excel software and plot a graph relate F and Q2. Comment on the graph, and this is the graph that we had. The second question, use the graph to find the electric constant K. So we use the same formula, which is the straight line formula, and we get 12.5 Newton square over Coulomb square. The last question is, calculate the percentage error in K. So we use the Coulomb's law formula and we substitute the value into the formula, and we also get 0%. Discussion. Coulomb's law is an experimental law of physics that quantities the amount of force between two stationary electrically charged particles. The electric force between charged body at rest is conventionally called electrostatic force or Coulomb force. For part 1, the graph F was inversely proportional with the distance r. It is because the force acts uniformly in all directions from the point source and conserves the energy over the entire surface surrounding the point object. The graph S versus 1 over r squared was directly proportional. Coulomb's law showed the force between charged particles is affected by the individual charge and the distance between them. However, the particle charge and distance always work together to affect the force. Finally, the unit of charge is called the coulombs. For part 2, the graph F versus Q2 was directly proportional. This is because electric potential at a point in a space is directly proportional to charge of source charge. For the deviation from the theoretical value, we could expect when we placing the two spheres at some distance in the link given, the difference between the actual distance of two spheres would not be a huge difference as electrostatic force is directly related to the charge of each object. Coulomb's law shows that the force between charged particles is affected by individual charge and the distance between them. Having a big different distance from the actual distance would affect the result. To get a better result, we should always bear in mind that the size of the charge should be much smaller than the aspiration. For example, if we encounter the charge rod 1 meter long and wish to determine the force it exerts on a small charge 50 cm away on its perpendicular bisector, and we simply apply the Coulomb's law, then we're not going to get the better result. We have to consider the force and infinitesimally small charge element exert on the test charge and result the process of integration. For the last slide is conclusion. Objective is achieved. Coulomb's law is satisfied experimentally. Coulomb's law states that the electrical force between two charged objects is directly proportional to the product of the quantity of charge on the object and inversely proportional to the square of the separation distance between the two objects. Second, the parameters that affect the electric force is studied. The force between charged particles were dependent on distance between the particle and the amount of the electric charge. Lastly, the electric constant K is found experimentally. When we plot for the graph F versus 1 over r squared and F versus Q2, the slope of the graph will represent the electric constant K. That's all from us. Thank